Hi friends, this is Chapter 5, Lesson 8. Go ahead and do these review problems and check your answers when you're done. Okay, here are your answers. Again, if you got 3 or more incorrect, I'd like to see before you start on the next, this homework practice. Okay, so today we're going to talk about finding the greatest common factor. That's what this stands for. Greatest common factor. Oops. There we go. Greatest common factor. What are the greatest common factors of monomials? A monomial is one term. Okay, so in the expressions that we've been dealing with, we have been using different vocabulary words to deal with different parts of the algebraic expressions. A term, remember, is either a constant, just a number, or a coefficient and a variable. Okay, so this is considered a term, that's considered a term. A monomial is just another word for one term. Okay, so we're going to talk about finding greatest common factor of monomials, and then to factor linear expressions. Okay, so we'll talk about that here. So find the greatest common factor of the pair of monomials. Okay, what we want to find is what is the largest factor that could fit into both of those terms. Okay, what is the largest factor? What's the largest monomial? What's the largest term that could fit into both of these monomials? Now, we can split it up like this. Okay, you want to get down basically to a prime number. Okay, this is sort of the long way route, but stick with me here for a minute. So 4x is made up of 2x times 2 times 2 times x. 2 times 2 gets us the 4 times x. This is just the expanded version of 4x, okay? Now notice 2 is a prime number, 2 is a prime number, 1 is a prime number, because remember that's really 1x there. Okay, so we want to get it down and expand it out until we have all prime numbers for each monomial. Okay, so, sorry about that. 12 then, we want to get it down to 2 times 2 times 3, so 2 times 2 is 4, 4 times 3 is 12, 12 times 1x is 12x. Okay, so now we have 2 times 2 times 3. These are the expanded versions, here and here, of our original monomials. Now, go through and circle the common factors. What are these two, which factors do these two monomials have in common? The 2's are in common, the 2's are in common, and the x's are in common. So that's the greatest common factor. So then a 4x and 2x is 2 times 2 times x. Okay, that's the expanded version, or 4x. 4x is the greatest common factor of both of those monomials. Now, another way you could look at this, 4x, 12x, think of it this way. Which number can I divide both of those by? What's the greatest common factor of both of those? If the variable is the same, then you're just looking at what's the greatest common factor for both of those numbers. You could see I can divide both of them by 4, right? So then I see that 4, and then I can also divide it by x. Right? 4x goes into both of those. 4x goes in here once, 4x goes in here 3 times. That's just another way of thinking through it there. Okay, you go ahead and find the greatest common factor of these two terms here. Okay, you should have got an answer of 4x. So again, you find the greatest common factor of the numbers of these coefficients because the variable is the same. Okay, so find the greatest common factor of the coefficients, which is 4 in this case. And then x also, of course, is part of that factor. It's part of the term. So 4x is the greatest common factor that goes into both of those monomials. Okay, find the greatest common factor of the pair of monomials here, 18a and 20ab. Okay, so notice we have this term, we've got a coefficient and a variable. This term, we have a coefficient and we have two variables. Okay, so we'll expand it out. 18a is 2 times 3 times 3 times a. 2 times 3 is 6. 6 times 3 is 18. 18 times 1a is 18a. And then also with 20ab is 2 times 2, which is 4, times 5, which is 20, times 1a, which is 20a, times 1b, which is 20ab. Okay, then we can circle our common factors. We see 2 is common here, and a is common here. And that's it. So the greatest common factor of 18a and 20ab is 2 times a, or 2a. Okay, again, we could have seen 18a, 20ab. I can divide this by 2a, and I can divide this by 2a. And both of them are going to go in. This is going to be 9, and this is going to be 10b left over, but both of them work out, and I can't divide any further. So that would be the greatest common factor. Okay, you go ahead and work this one through on your own. Check your answer when you're done. Should have gotten an answer of 8s, 16s, 40st. Again, I can go in, divide that by 8s. I can divide this by 8s. I get 2 there. I get 5t there. Both of these are prime numbers, and t is not over in this monomial here, so then I know that 8s is my greatest common factor. Okay, find the greatest common factor of the pair of monomials here, 12cd and 36cd. 12cd expanded out is 2 times 2, which is 4, times 3, which is 12, times c times d. Now notice again, prime number, prime number, prime number. When you're expanding out a monomial, you want to get down to all prime numbers. That is how we find the greatest common factor, all prime numbers. And then 36cd is 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36, times c times d. And then we circle our common factors. We see that I have everything in common except for that last 3. So what we have in common between the two is 2 times 2 times 3, right? 2 times 2 times 3, these 3 circles, times c times d. And then you factor that out. 2 times 2 is 4, 4 times 3 is 12, 12 times c is 12c, and 12c times d is 12cd. Go ahead and work this one through on your own. Should have gotten the answer of 14ab. 14ab, 28ab. I can divide this by 14ab and this by 14ab. I get an answer of 1, and I get an answer of 2. Those are both prime numbers. There's no variables hanging out there, so that is going to be 14ab is our greatest common factor. Now, when it says to factor 3x plus 9, this is just kind of going a little bit backward, okay? So we're going to skip method 1, unless if that makes sense to you, okay? So if you need the visual, then come see me and we'll work it through together. But otherwise, we're going to use the greatest common factor. So when we look at 3x plus 9, we divide 3x out into 3 times x. And when we look at 9, we can divide that out into 3 times 3. Okay, so this is just expanding out the different terms that are in that expression. 3x is 3 times x. 9 is 3 times 3. Okay, and then you circle the common factors, which is, in this case, 3. So the greatest common factor of 3x and 9 is 3. So we will write each term then, each of these terms, as a product of the greatest common factor and then whatever its remaining factor is. Okay, so in this case, 3 is our greatest common factor. So in this case, we need to take the greatest common factor times x in order to get this original term, 3x. Right? 3 times x, greatest common factor, and then whatever is left over the term, 3 times x, and then 9 is the greatest common factor, which is 3, and then times whatever is left to get 9, which in this case is 3. Okay, so 3x plus 9 equals is the same as 3 times x plus 3 times 3. Then we can use the distributive property to put this 3 on the outside, put a parentheses, x plus 3. Right? If I'm multiplying here and here by the same term, by the same number, then I can put together the terms on the inside of the parentheses with the sign, this is addition in this case, and bump that greatest common factor to the outside. Okay, so basically 3x plus 9 is the same thing as 3 times x plus 3. And again, if I would check my work here, I take 3x, 3 times x is 3x, 3 times 3 is 9, 3x plus 9 is indeed the right answer there. Okay, go ahead and factor this one out. Use the greatest common factor, and then split it up into the factored form. Okay, you should have gotten an answer of 12 times x plus 4. Greatest common factor between these two terms is 12. Notice it's not 12x because 48 doesn't have an x, so it's just plain old 12. If I divide both of those terms by 12, I get an answer of x plus 4. But if I divide it up by 12, I need to be able to multiply it again by 12. So this is what I can do here. I can solve that and get my original term, or I'm sorry, my original expression. So then I know that this is the factored form, the simpler form of that expression there. Factor 12x plus 7y. So we find the greatest common factor of 12x and 7y. 12 is 2 times 2 times 3 times x. 7y is 1 times 7. Right? Prime numbers is all we got to work with. 1 times 7 times y. And there's nothing to circle. There are no common factors between those two monomials. Therefore, 12x plus 7y cannot be factored. Okay, you will run into some of these where you can't factor this out because there are no common factors between your two monomials. You can't simplify it anymore. And that might be the case for some. So go ahead and work your way through this one. Check your answer when you're done. Okay. Similarly, this cannot be factored. There is no common factor between 3x and 11. They are both prime numbers. The x is not shared between the factors. Now, if we would have 3x plus 11x, then there would be a common factor. We would have the x there, and then we could write it like this: x times 3 plus 11, and that would be our answer. But that there is no x to share. There is no common factor to share at all. So that means it cannot be factored. Okay, the drawing of the garden at the right has a total area of 15x plus 18 square feet. To find the possible dimensions of the garden. Okay, so first of all, we want to factor out 15x plus 18. 15x is 3 times 5 times x. 18 is 2 times 3 times 3. Circle the common factors, which is, in this case, the 3's. So the greatest common factor of 5x and 18 is 3. Now, we have that greatest common factor, which is going to go on the outside of the parentheses. Okay, so then we have 3, greatest common factor, times 5x, which is what's left over here. Right, so this, the 3 is crossed out because we have that as our greatest common factor. What's remaining? 5 times x. So 3 times 5x plus 3, greatest common factor, times 6. Where did the 6 come from? When we factored this out, or expanded it out, we have 2 times 3, which is 6. So 3 times 5x plus 3 times 6. Then we use our distributive property to be able to rewrite that expression, put the 3 on the outside of the parentheses, put 5x plus 6 on the inside. So the possible dimensions of the garden are 3 feet by 5x plus 6 feet. Okay, whatever that would end up being, that's the possible dimensions. Now notice, by in a word problem means multiplication. So what they did here is you're multiplying 3 times the inside of the parentheses. So it's 3 by 5x plus 6. Okay, go ahead and work this one through on your own. Check your answer when you're done. You factor that out, you should have got an answer of 3 inch by x plus 4 inches. When you are all said and done, it would look something like this, x plus 4, but then in the word problem, they're looking for dimensions, so it's 3 by, which is multiply, x plus 4. Okay, so we've learned how to look for the greatest common factor in algebraic expressions, and then to factor that out, put it into its factored form where that greatest common factor is on the outside of the parentheses, and then whatever is left over is on the inside of the parentheses.